So now we are clear with what is meant by big omega and what is meant by big O, right? Two notations we learned. Now we will try to understand what is meant by theta notation. Okay, theta notation. So this is one of the notation in asymptotic notation. These notations are used to represent our complexity of an given algorithm, right? That is what. So now same as how we understand big O notation and big omega notations. For example, if this is my f of x, this area represents big O notations, right? And this area represents big omega notations. So big O notation represents upper bound and big omega represents lower bound, right? So while finding the big O notation, big O for given f of x, we will try to find a line, a function, another function which will be multiplied by a constant positive number c and with m0, and same as if this can be a big O of and this can be a big omega line. So now coming to for theta representation, for theta notation. So theta notation is actually very tightly bound notation. We will say by majority of the time while we are calculating, while representing, we will utilize theta notations compared to big O or big omega. But as I earlier mentioned, we can represent in any one of the form whichever you are okay with. So now what is meant by theta notation? So theta notation is very tightly bound. So that means it will provide a range. So that the actual complexity of your algorithm will fall into that particular region, that particular range. For example, if this is my f of x line, so theta notation will provide me a range. So this is the area theta notation will represent. So our complexity of your algorithm will fall between this and this. Okay, so theta notation will provides a range so that the actual complexity of your algorithm will fall under this area. That means this is very tightly bound. So now, as you see, these are also two another lines that are forming in this graph. So this can also be represented as another function, right? So my f of x is 3 plus 3n square plus 3. Let's imagine this is my f of x, 3 multiplied by 3n square plus 3. So what is my f of x? 3 multiplied by n square plus 3. So we can translate as 3n plus 3. This is my f of x. So I need to find this class and this class so that it will provide me a boundary. So how can we use? So I will remove this 3. So I will simply make this as n square plus 3 is always lesser than or equals to 3n square plus 3. And same way, instead of 3, let's place 10n square plus 3. So that this 3n square plus 3 is always lesser than or equals to 10n square plus 3. So here we can eliminate these three values and these constant values. So what is the highest degree of our n here? 2, right? 2. So we can say our theta is n square. So my f of n equals to theta of n square. So for this function, what is my theta? Theta is n square. F of x equals to n factorial. So what is meant by n factorial? What is meant by n factorial? N multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus 3, so on, 3, 2, 1, right? This is my n factorial equation, right? So this is what, if my n is 3, then what I will do? 3 multiplied by 2 multiplied by 1. So this is our n factorial. So what will be the n factorial? What will be the theta? When you want to identify theta notation for n factorial. So what is my f of n here? F of n is n factorial, right? So n factorial can be represented as n multiplied by n minus 1 multiplied by n minus 2 multiplied by so on 3, 2, 1, right? So we need to identify these two clauses now, right? This is what exactly we need to identify. Let's imagine C1, let's take it as 1, right? So n minus 1, so just replace 1 multiplied by 1, so on, up to n, okay? In the same way, here C2 just take 1. So here n minus 1, n minus 2, like this is there, right? So this value should be always lesser than or equals to C2 multiplied by G of n. So what we will do, we will multiply n multiplied by n, n multiplied by n, so on up to n times. So based on our input, if my input is 5, I will multiply 5 once here, that will be multiplied by C1, and if my input is 5, I will multiply 5 times here, okay? So that this value will be always lesser than or equals to this value, right? So now let's see what is the problem here. What is the problem here? Let's see. See here, what is actually it is representing? Can anyone tell? So what exactly this means? 1 multiplied by n multiplied by n times. So this can be represented as n power n. This can be 1 multiplied by n number of 1 times also. This can be represented as 1, right? So I will translate here 1 less than or equals to n factorial less than or equals to n power n. This is what we got the result. See here, if you observe this and this, it looks like the range now will become this is almost like constant value, 1, right? Constant value. This is n power n means somewhere like this. So the range is very much high here. So the range is very expanding. So and in this case, we can't say the tight bound complexity for n factorial because the range is very much higher compared to other functions. For this function, there is no theta. We can't represent it in theta notation, but we can represent it in, this is my lower bound, this is my upper bound. So this is my big O notation, this is my omega notation, but there is no theta notation for n factorial, right? There is no theta notation for n factorial. But whereas in previous case we are able to find, because the range we can, if you imagine, that will be okay, but in this case this is least one. If my n value is, for example, very much big, then this range is also expand like anything. So that won't provide us the tight bound complexity for our algorithm. That's why for n factorial there is no theta notation, but whereas we can represent it in asymptotic notation of lower bound big omega notation, that is one, and big O notation, that is n power n. For n factorial, what is the complexity of n factorial algorithm? The complexity of n factorial algorithm can be represented by big O notation or big omega notation. So what is my big omega notation? F of n is n factorial equals to big omega of 1, and same way my f of n equals to n factorial equals to big O of n power n, but there is no theta notation for this n factorial.